looking at lesson 10.4, inverse of a function. Now, before we get into our new lesson, I want to ask you something that you have learned before that you should already know. If I were to give you the linear equation y equals mx plus b, and I asked you to write it in function form, what one thing would you have to remove from the linear equation, and what would you replace it with? Replace y with f of x. Remember, y and f of x are the same thing. They're interchangeable. So by removing the y and plugging a f of x in its place, you have just written the linear equation as a linear function. So the essential question today says, how are a function and its inverse related? So we're going to take functions and we're going to write the inverse of those functions, okay? In a sense, the opposite of those functions. An inverse relation switches the input and the output values of the original relation. So we're going to see that a lot today. We're going to be switching our input and our output. But what variable typically represents for us our input values? An x. If you want to put x above input, that would be a great idea, which makes our output values what variable? Y. All right, so throughout this lesson today, you're going to see us switching x and y a lot. All right, in an ordered pair, they're using a, b, but we could put x comma y as the relation. The inverse means we simply take the x and y and we flip them. So y is now first and x would be second. And that's going to make example 1 super easy. It says find the inverse of each relation. So we have these ordered pairs and we should be able to switch the x and the y coordinates pretty quickly. What would be the inverse of the ordered pair -4, 7? 7, -4. What would be the inverse of -2, 4? 4, -2. What would be the inverse of 0, 1? And what would be the inverse of 2, -2? And what would be the inverse of 4, -5? There we go. So these are the inverse. Okay? These are the inverse of the original function. That means if I were to graph those ordered pairs, the original ordered pairs, and then I were to graph the inverse, I would have two graphs that look the same but are going different directions on the graph. They're inverses of each other. All right, now look at letter B. We still have ordered pairs. I've just put them on an input-output table. Again, the input is which set of values? X, and the output is Y. All right, so I've given us a new table, and we're just going to put the inverses on this new table. So -2, 4 is going to become what? 4 in the input box, -2 in the output box. All right, what about -1, 1? 1 in the input, -1 in the output. What about 0, 0? It's not going to change because the numbers are the same. What about 1, 1? Still 1, 1. And what about 2, 4? 4, 2. All right, so if you're given an ordered pair and I ask you for the inverse, you simply switch the x and the y. Now, in this problem, they're also asking us to do something that should look familiar. They're asking us to solve y equals f of x for x. So right off the bat, they're telling us something that we already know. We already know that y and f of x are equal to each other. They're interchangeable, okay? What they're asking us to do then is to solve for x. So if you go all the way back to chapter 1, we've already learned how to solve literal equations. These were equations that had more than one variable in them, and you could be asked to solve for any of the variables in the problem, and you would just have to get that variable by itself. So that's what's happening in these problems. We're going to have an x and a y, but they are asking us to get x by itself. So looking at letter A, right off the bat, we're going to change that f of x to a what? A y. And y equals x minus 6. The rest of the problem stays the same. Go ahead and highlight. They've asked us to solve for x. So if we're trying to get x by itself, what are we going to have to move away from that x? The 6. And how are we going to move it? It's a -6 or a -6, so we're going to add it. Now, it cancels over here. Are we able to combine the y and the 6 on the left side? No, they're not alike. So I'm going to go ahead, because you know me, I like my variable that I'm solving for on the left. So I'm going to go ahead and put x equals, and then I'm just bringing down y plus 6. I can't put them together, okay? So I just bring them down separately. Now, I've done what they've asked. I have solved for x, so this is the first thing that I'm boxing in. Now, if you continue to read the directions, it says, then find the input when the output is 4. And you can see after the word input, I put X because X is our input. After output, I put Y because Y is our output. So basically, they are telling us that Y is, or the output is what? 4. So what are they wanting us to do with that 4? Plug it in place of what? The Y. So we go right underneath the equation that we've written, and we're going to put X equals, take the Y out, put the 4 in, and what is the value of X? 10. When Y is 4, X is 10. And that is the second answer that they are looking for. Or B, what's the first thing that you did? Change f of X to Y and bring down X equals, or Y equals 4X squared. Now again, what are we trying to solve for? And right now our X is squared, and that's okay. We still got to get it by itself, so what do we do next? Divide both sides by 4. Can we actually do Y divided by 4? No. So we have Y divided by 4, and it equals, because this simplifies to a 1, it equals X squared. Now, we need just X. So how do we get rid of that squared? We square root both sides. And we put the radical into the problem, so what else do we put into the problem? Our plus or minus. And again, remember, it goes away from the squared term. It goes on the other side. So, what is the square root of X squared? X, and it equals plus or minus the square root of Y divided by 4. Now, what have I taught you to do when there is a fraction underneath the radical? Separate them. Very good. So we're going to do X equals plus or minus the square root of Y divided by the square root of 4. Because we want to check, will either of those simplify? Yes, which one? Okay, so we have X equals plus or minus the square root. I'm going to drop this down just a little bit. X equals the square root of Y plus or minus divided by what? 2. So here is my equation solved for X. All right, now for the second thing they're asking us to do, again, what are we going to do with that 4? Plug it in place of Y. So we have X equals plus or minus the square root of 4 divided by 2. What is the square root of 4? And what is 2 divided by 2? So X equals plus or minus 1. Now, looking at the next example in your notes, you're going to notice underneath the directions I have put these 4 steps. Okay? These 4 steps are what you need to write an inverse function. Okay? So here's step number 1. We've been doing this all lesson so far. We're going to change f of X to Y. Then we're going to switch the X and the Y. So we're going to take the variables X and Y and we're going to switch them. We're not going to switch any signs. We're not going to switch any exponents. We are not switching any equal sign. We are just switching X and Y. Then we're going to solve the equation for Y. Okay, we're going to get Y by itself. Then we're going to change Y to G of X. So we're taking it and putting it back into function form. Why am I not putting it back to f of X? Already in f of X. Remember, we're writing an inverse function. We're writing a new function. So we can't give it the same f of X. We've got to give it something different. We could do h of X. We could do really anything we want. But we're going to do g of X just so everyone's on the same page. Okay? So highlight those steps underneath example number 3. And then let's follow them. And let's work letter A. So the first thing we're supposed to do is what? Change the f of X to a Y equals negative X plus 5. What is step number 2? Switch X and Y. Now watch. I'm taking the Y and I'm changing it to an X. I am bringing down equals and the minus sign, and the X becomes a Y, and I bring down the plus 5. So do you see what I mean when I say no signs are changing? The only thing we're doing is switching X and Y. Now, we're supposed to be solving for what in step 3? Y. Okay? So what do we want to move first? We move the 5 by subtracting it. Now again, can we do anything with X minus 5? No. So we just bring it down and it equals negative Y. Are we finished? Why not? There is a negative in front of the Y, which means there is an understood what in front of the Y? A negative 1. So I got to move that. How do I move it? Divide it by negative 1. Now remember, what I do to one side, I have to do to the other. And listen, I have to do it to every single term. I cannot pick and choose. So when you divide the left side of this problem by negative 1, make sure you divide both terms by the negative 1. So, what is x divided by negative 1? Negative x. And what is negative 5 divided by negative 1? Positive 5. And of course it equals, because our 1's simplified to 1, we are left with y. Now, are we finished now?
No.
Why not? We have to change the y back to function form, and we are using g of x. So g of x equals negative x plus 5. Now, let's try it again with letter B. What do we do first? Change f of x to y, and it equals 1/4 x minus 1. All right, what's step 2? Switch x and y. So the y becomes an x. I bring down the equals. I bring down the 1/4. The x becomes a y, and I bring down the minus 1. What am I trying to solve for? Y. So what do I have to move first? How do I move the 1? I add it to both sides. Can I combine x and 1? No, I just have to bring down x plus 1, and it equals 1/4 y. Now, we haven't seen this in a while. We need to move a fraction that's being multiplied by a variable. What's the shortcut that we learned? To move that fraction quickly, multiply both sides by the reciprocal. Now remember, okay, it's the same thing. What I do to one side, I have to do to the other, but I have to do it to everything on the other side. So I'm either going to write 4 times x and 1 times 4, okay, or I can just put the times 4 once and put the binomial in parentheses, and then I just have to remember to do what property? The distributive. So however you see that more easily, that's fine. But just make sure all your terms get multiplied by the 4. So that is 4 times x is 4x plus, what's 4 times 1? 4. And of course over here this simplifies to a 1, leaving you with just y. All right, am I finished?
No.
What's left? Change the y. So g of x, and we're going to put it first, equals 4x plus 4. Now, I want you to go back to letter A, and I want you to look at the original function, and I want you to look at the new function. What do you notice about them? It's the same, all right? And the reason I did not point this out to begin with is because I did not want you to think that this is going to happen every time. I didn't want you to think, oh, well, they're going to be the same, so I'm just going to replace f of x with g of x, and I'm going to be done, okay? Because look at letter B. Is that the case? Are they the same in letter B? No. So what happened in letter A is very rarely going to happen. So make sure you know your 4 steps, because that right there in letter A rarely happens. This is more of what's going to happen, what we did in letter B. So know your 4 steps, and you should be in good shape. Are there any questions? All right, now look at this last example. They've asked us to do 3 different things, and we're going to focus on one at a time. The first thing they asked us to do is find the inverse of the function. So looking at letter A, now I would highlight, because we're seeing something again we haven't seen in a while, and that is a boundary. That x is less than or equal to 0 is a boundary. So highlight the function so you can focus on what you're finding the inverse of. All right, what's step number 1? F of x. Don't say change it to y. Tell me exactly what I'm changing. I'm changing f of x to y, and it equals negative x squared. All right, someone new, tell me what I do next.
Switch to y.
Okay, I switch. The y becomes an x. I bring down the equals, the negative sign, the x becomes a y, and I bring down the squared. Again, x and y are switching. Nothing else moves. All right, what's my goal? To isolate what? Y, and right now it's a y squared. What do I move to get y squared by itself?
Divided by negative.
There's an understood negative 1 in front of y squared, so yes, I'm going to divide both sides by negative 1. What's x divided by negative 1? Negative x, and it equals, of course, y squared. How do I get rid of the square? I square root both sides, and I put the radical in, so what else has to go in? The plus or minus. Again, it goes on the side away from the squared term. So it's not on the side with y squared, it's on the other side. So what is the square root of y squared? Y. So y equals plus or minus the square root of negative x. Now let's talk about this for just a second. What causes you to stop and go, I can't work this problem anymore? There's a negative under a square root, but let's go back to the boundary that we talked about. Do you see the boundary of our function? It says that x has to be less than or equal to 0. What kind of numbers are less than 0? Negative. So let's pick a negative number. Let's say we're plugging a -2 in for x. All right? That would be the opposite of -2. So every time we plug a negative number in for x, what's going to happen under the radical?
Positive.
The double negative is going to become a positive. So can we move on with this problem? Yes. Now, here is the question we have to answer. Right now, we have a plus and a minus in front of the radical. And we know that when we plug in a value for x, we're coming up with our y value. So, are we keeping the positive sign or are we keeping the negative sign? Well, let's go back to the boundary. If our x's are going to be less than or equal to 0, then what do our y values need to be? Negative as well. So, am I keeping the plus sign outside the radical or the minus sign? If we want our answer to come out to be negative, like Isla said, remember, this is going to come up to be positive every time. So we need which sign on the outside if we want our y values to also be negative? We need the negative sign. So we're going to rewrite y is going to become what? G of x, and it's going to equal the opposite of the square root of -x. And we're boxing it in because that's the first thing they asked us to do, was to find the inverse of the function. All right, now we're going to graph the function and the inverse. Let's start with the function, and we've got y equals, what was the function? The original function. Negative x squared. Now, what kind of graph are you looking at right now on your Desmos? A parabola. However, we're not done with that original function because it had a boundary. Now, if you need to add notes, you can. We've done this before, but you might have forgotten. You hit the keyboard button, hit the ABC button, and remember these braces. You've got to click on the brace button. Then you go back. Actually, make sure you're out of the power or the squared. Then hit the brace and put in the boundary. It was x is less than or equal to 0. And then you hit enter. Now, instead of the full parabola, we have what? We have half of it, okay? Now, we're going to keep ourselves consistent through this whole chapter, and we're going to put 3 points on our graph. We did it in 10.1 and 10.2, so we're going to do it in 10.4 as well. Give me a point, an obvious point that we need on this graph. 0, 0, all right? The end point, which means, are we going to have an arrow on that end? No, we've got an end point. All right, give me another point on this graph. -1 and -1 is what I heard. So -1, -1 is absolutely on this graph. All right, give me one more point. All right, -2, -4. Now make sure on your notes you have all 3 points. Make sure they are labeled. And then what do we need on the other side of this graph? An arrow. So after you plot -2, -4, draw your line. Give yourself a little extra line past -2, -4, and put your arrow. Let's put in the inverse. All right, we're going to use y again, but y equaled the opposite of the square root. There's your square root button right there on the keyboard, the main page. And then it was -x. Now, do you see? And remember, you can change the colors of these if you want to. I'm going to change it to blue. Okay? Do you see how it is the same shape, but it is going in a different direction? Now, what 2 points do you already have for the new graph?
0, 0,
You already have 0, 0, -1, -1. So you just need one more point, and then you're going to draw the inverse. So what's one more point that we can add? -4, -2. Perfect. And then after you put -4, -2, what needs to go on that end of that line? The arrow. Again, give yourself a little bit of line so you can put an arrow on just that end. Now, you've graphed the function, you've graphed the inverse. The last thing they ask us to do is to decide if the inverse is actually a function. So if you go back to linear functions, I want you to go back to chapter 1. All right, there was a test that we performed. When we were given a graph and asked if our graph was a function, there was a test that we had to perform. Does anybody remember what that test was? Joel?
That intersected with another line.
The vertical line test. We drew an imaginary or a dotted line through our graph, And if it hit the graph one time, we knew it was a function. So to check the inverse of a function, we're going to do the opposite of a vertical line test, and we're going to do a horizontal line test. So same idea. We're going to draw an imaginary, in our mind, horizontal line, or you can draw it on paper, make it dotted. I would suggest looking at Desmos and doing it on Desmos because we're not always the greatest at drawing on our paper. So to make sure we don't get confused, I'd look at Desmos. But remember, my horizontal line is going through the blue. We're checking the inverse graph. So I could start my imaginary line here if I wanted to. I could start it down here if I wanted to. No matter where I put that horizontal line, how many times does it go through the inverse graph? One line, guys. You're just looking at one line. I drew two different lines because somebody might start that line high, somebody might start it low. How many times? You're just looking at the blue line. One time, right? Remember, we already know the red line. We already know the original function is a function. We're checking the new one, the inverse. So how many times does that horizontal line go through the blue graph? One time. So is the inverse a function? Yes. So the last answer you're going to write down is the inverse is a function. Box it in, and you're finished. And that's 10.4.